Okay, welcome to Imaginary Numbers or the Imaginary Unit. And what this is actually it's a very terrible name for something that turned out to be super, super useful once they kind of accepted this idea. So basically what happened was if we're looking at x squared minus 1, if we went to solve this algebraically, subtract 1, we would get x squared is equal to negative 1. So the square of a number is equal to a negative number. For a really long time, it didn't necessarily exist. Okay, so if I took this, I would say x is equal to plus or minus the square root of negative 1. So after some time, the mathematicians decided that, well, okay, what happens if this were true? What happens if this were true? And what they did is they called it I. And I stood for an imaginary number or a number that didn't really exist, but it turns out it's very, very useful. And what's super, super unique about I is it kind of works in a pattern. So you can see here I is equal to the square root of negative 1. I squared is equal to negative 1. I to the third is equal to negative I. And then I to the fourth is equal to positive 1. And you can see it keeps repeating I to the fifth power, sixth power, 7, 8, right? And it repeats over and over and over again. And that's what makes this group of numbers super, super, super unique. Okay, so just in short, what you really should know is this, that I squared is negative 1, and that I is equal to the square root of negative 1. So that's really the definition of this number called I, this imaginary numbers. Okay, so let's kind of break it down and show you how this I works with our applications and our numbers here. First of all, understanding perfect squares is going to be super, super helpful. So if you need to copy down a list, right, usually up to 20 is about good. But if you want to know more, you can always find more. And then if you want to put it in your calculator, you can go y equals x squared into y1, and then you can look at your table and it will also generate this same list. Okay, so first of all, what exactly does it mean here? All right, what exactly does it mean here? The square root of negative 18. Okay, so in the past, we told you that this is a non-real answer. That's true. All right, so how we're going to have to break this down is into a couple of different things here. First of all, divide out the square root of negative 1, and then find perfect squares to simplify. So if you look at the list of perfect squares, what perfect square goes into 18? And you can see 9 is the value that goes into 18. So 9 times 2 is 18. And then we're breaking this down into simplest radical form. All right, so here we go step by step. The square root of negative 1, you now know, is this number I. The square root of 9, you know, is 3. And the square root of 2 remains the square root of 2 because there's nothing we can break it down any farther with any of the perfect squares. So this should be written like 3i radical 2. And that is the simplified version of the square root of negative 18. So you can see in example number 2, right? Very, very similar. How are we going to break this down? First of all, right away, write the square root of negative 1. Okay. Then determine, can we break down 200 into perfect squares? So if you look at the perfect squares list again up top, or use your calculator, you can see 100 is the value there that we can divide out, because 100 times 2 is 200. Now you can see here, we can go the square root of negative 1 is I, the square root of 100 is 10, and then the square root of 2 remains the square root of 2, it remains an irrational number, and we leave it as is. Now in proper format here, we should write 10I radical 2, because you don't want that I to get lost underneath the radical. And there's the simplified version of this, okay? Then if we're looking at the square root of negative 245, okay, right away, let's break this down into the square root of negative 1. And let's see if we can break 245 down into two perfect squares. All right, so now using our calculator here, right, we can determine if we want to, if I go into here and I type in 245 and then I divide it by x, now I can use this table here to look for numbers. So if I go ahead and look for numbers, are there any perfect square numbers in here that you can see? Right, and very clearly I see 49 because 5 times 49 is a perfect square. So if I go back, I can separate this into 49 and then 5. And then I follow the same steps. The square root of -1 becomes I. The square root of 49, if we look back up to our table, is 7. Right? The square root of 49 is 7. So this turns into a 7, and then the square root of 5, there's nothing I can do that remains an irrational number. Right? So then I would write this as 7i radical 5, and then you are done. Okay? And this last quick example is sometimes there's nothing you can do. You can't simplify this any farther. So this would break down into I. Well, let's do this a little bit slower. The square root of -1 times the square root of 3. And then the square root of -1 becomes I, and then radical 3, there's nothing you can do. So you just leave it exactly like that. Okay, so you have I radical 3 for that one. So that's an example on how to simplify the square roots with negative numbers. Okay, so now we're going to look at how this behaves here. Right, we want to write this in a plus bi form, meaning that the imaginary numbers can't be combined with real numbers. So let's just go through this slowly. The square root of 4 is 2 minus. Now you should know right away that the square root of 4 is 2, and then since it's negative, we have an I, plus the square root of 64 is 8, plus the square root of -36 is 6i. Notice how I didn't change that plus to a negative number. That remains a positive. And what the imaginary numbers work like are like terms. So I've got -2i and I've got 6i. And then I've got 2 and then I've got +8. So 2 plus 8 is 10. And then -2i plus 6i is plus 4i. And you can see that now it is written in a plus bi format. And that means a real number here in the first part, and then an imaginary number in the next part. And you're going to see in the next unit why that's important to write it in that order. So whenever you're adding these numbers, you just want to treat them like terms. You want to treat them like terms. For example, let's look at this one and see how we can break this one down. All right, so first of all, I've got a negative. The square root of 4 is 2. Minus, now this one, we've got to break down a little bit more, right? I've got the square root of -1 times 2 values that go into 45. Now, if you're not sure, again, look at your list, use your calculator, but 9 times 5 is 45. So you're going to see here that the square root of -1 is I, the square root of 9 is 3, and then we've got radical 5. And if we keep working our way over here, I've got minus, and the square root of 36 is 6. And then I've got another minus, and we're going to break this down, right? The square root of -1. And then what divides into 180? Now again, if larger numbers, let's just go back to our calculator. We're not sure. All right, we're going to say, well, 180 divided by all the numbers. Okay, so we're going to go ahead and take a look at this one. Now this is interesting here because we've got 2 times 90, 3 times 60, 4 times 45, 5 and 36. 36 is the perfect square that we're looking for. So 36 times 5 is what we want. And again, if you're not sure what your perfect square numbers are, all right, use your list, okay, or use your list in your calculator, but 36 you can see is right there. All right, so this one is going to break down to the square root of 36 times the square root of 5. Now, if we simplify this, the square root of 36 is 6i radical 5. And you can see very clearly that now these are like terms here because they have an I and they also have the same square root value. So let's combine like terms. So negative 2 minus 6 is negative 8. And now we have 3i radical 5s and 6i radical 5s. They're both negative, so we're going to write minus 9i radical 5. So you can see now that this is written in a plus bi format, where the real number is first, and then even though there's an irrational number involved in here, if an I is involved, this is the imaginary aspect of that value. Okay? All right, now what happens when we multiply these numbers together? So when we multiply these numbers together, what we're going to do is we're just going to list everything out. Okay, so I've got negative 9 times this. I'm going to pull out the square root of negative 1 and the square root of 9 and the square root of 6, because 6 times 9 is 63. And then I'm going to write for here, right, negative 1 times this square root of negative 1 times the square root of 49. Okay? So just with these problems, you just kind of go step by step by step. So now I've got negative 9. The square root of negative 1, you know, is I. Square root of 9 becomes 3. Square root of 6 is the square root of 6. There's nothing we can do. Negative 1 remains negative 1. This becomes I, and the square root of 49 becomes 7. Okay, so you can see we're multiplying all these numbers together. Okay, so if you can, I would definitely use your calculators and start with the numbers first, right? So I've got negative 9, I've got 3, I've got negative 1, and then I've got a 7. Okay, so we just multiply in our calculator, negative 9 times 3 times negative 1 times 7. We would do, I forget that already, looking back and forth. It's negative 9 times negative 1 times 3 times 7. Oh, okay. Let's split the screen here so we can look at both, all right? All right, so I've got negative 9 times 3 times negative 1 times 7, and I've got 198. So you can see right here, the numeric value is positive 189. Sorry, 89. And you're going to see what's left. Well, I've got an I left here. And then if I keep looking, I've got another I left here. So I'm left with an I squared. And the last thing that I have left is this square root of 6. Okay. Now, what's super, super important, what we understand here, is that anytime you see an I squared, this changes to a negative 1. So what do we get? We get negative 189 square root of 6. Okay. Moving on to one that's a little bit simpler, but might be a little bit confusing at first here. So what can we do here? Well, the negative is going to remain on the outside, negative 1. This can get separated into the square root of negative 1 times the square root of 2. And then this gets separated into the square root of negative 1 times the square root of negative 5. So again, step by step, right? If I move this step down, I can see very clearly here, right, what is going to be coming next. Well, negative 1 is going to remain the same. Square root of negative 1 becomes an I. Square root of 2 remains the same. Square root of negative 1 becomes an I. Square root of 5 remains the same at the square root of 5. So again, if we're doing this step by step, it becomes a little bit easier to see. So first, let's deal with the numbers. We've got negative 1, and that's the only number we have. The next thing we have is an I and then another I. So I times I is I squared. And then the last thing we have to deal with is radical 2 times radical 5 is radical 10. So we can see here that now we have negative 1 times the square, or I squared also becomes negative 1. And then radical 10, there's nothing we can do. So negative 1 times negative 1 is positive 1. So our answer to that would simply be the square root of 10. Okay? All right, last little bit here is the powers of I, which we're going to do in a second video. So you can see this in the second video, how to evaluate the powers of I.